Bonjour, bon, bon qui, bon, bon oui, bon oui. Oh, I love this French. Oh, hello there, grade 7. How are you doing? Welcome back to my channel. What you just have witnessed is me learning a French language. I'm learning French so that when people or someone talks to me in French, I can understand what this person is telling me. Just like in math, we are going to learn another set of terms in algebra. We have to understand these terms so that when your teacher uses these terms, you will be able to understand what your teacher is telling you or trying to say. Are you ready? Make yourself comfortable and let's have a journey towards unfamiliar terms. In the previous video, we discussed about algebraic expressions, the introduction of algebraic expressions. In this video, we're going to talk about polynomial. What do you mean by polynomial? Before I'm going to give to you the definition of polynomial, let's recall first the definition of an algebraic expression. An algebraic expression is a constant. When we say constant, it's a specific number. It's a real number. It can be 5, it can be -10, it can be 1 million. An algebraic expression can also be a variable. When we say variable, it's a letter or a symbol representing a known number, just like X, Y, Q, P, and so on. An algebraic expression can also be a combination of constant and a variable. These are some examples of algebraic expressions. We have 8x cubed plus 4x squared y squared. We also have x squared over 2 plus 5x minus 7. We have 3 over x squared. We have 4x raised to 1/2 minus 2. And the last one is 3 raised to 2. The last one is a constant. And the rest of the examples here are a combination of constants and variables. Now, what is polynomial? A polynomial is an algebraic expression whose literal factors have whole number exponents. A polynomial is an algebraic expression, meaning to say it can be a constant, or it can be a variable, or a combination of both. But take note, the exponents of the variables should be whole numbers. There should be no negative exponents. There should be no fraction exponents. Let's identify what the polynomials are from the examples above. The first polynomial is 8x cubed plus 4x squared y squared. How did I know that this expression is a polynomial? Just look at the variables. Just look at the literal factors. If the exponents of the literal factors or the variables are whole numbers, then the given expression is a polynomial. The exponent of x here is 3. It's a whole number. The exponent of the other x is 2. It's also a whole number. The exponent of y is 2. It's also a whole number. Therefore, this algebraic expression is a polynomial. Next, the other one is x squared over 2 plus 5x minus 7. All the exponents of x in this algebraic expression are whole numbers. What are these exponents? We have 2 for x squared and 1 for x. By the way, x is understood to have an exponent of 1. And the third one is 3 squared. This is a polynomial. Remember, a polynomial is an algebraic expression, meaning to say it can be a constant, All constants are polynomials. 3 squared is a constant. It's the same as 9. It's a polynomial. Now, 3 over x squared is not considered as polynomial. Why? Sir, the exponent of x is 2 and it's a whole number. Yes, you are right. The exponent of x is 2 and it's a whole number. But look at the location of x. Where is x located? Is it in the numerator or in the denominator? If your answer is the latter, then the given expression is not a polynomial. 3 over x squared can be written as 3x raised to negative 2. Notice here that the exponent of x is a negative number. And a negative number can never be a whole number. That's why this is not considered as a polynomial. What about 4x to the 1/2 minus 2? Why is this not a polynomial? Look at the exponent of x. It's 1/2. Not all fractions simplify to a whole number. 1/2 can never be a whole number. Therefore, this is not a polynomial. All right. Let's go back to the first polynomial, 8x cubed plus 4x squared y squared. This expression has two terms. What are the terms? 8x cubed, 4x squared, y squared. If a given polynomial has exactly two terms, then that polynomial is said to be binomial. It's from the prefix bi, means two. Let's have the second polynomial. X squared over 2 plus 5x minus 7. This expression has 1, 2, 3 terms. It has 3 terms, therefore, this is called a trinomial. Trinomial from the prefix tri, which means 3. And for the last polynomial, 3 squared, it has only one term. And if a polynomial has only one term, then it is called a monomial. Monomial from the prefix mono means one. These are the types of polynomial. We have monomial, one term, binomial, two terms, trinomial, 3 terms. Let's have the degree of a polynomial. What do you mean by degree of a polynomial? Degree can be understood as the highest attainment a person has achieved. For example, in my case, if someone will ask about my degree, I'm not going to say, I am a high school graduate. Yes, I am a high school graduate, but that is not the highest education I have achieved. My answer should be, my degree is Bachelor of Secondary Education, major in mathematics. That's the highest education I have achieved. So how we are going to apply that concept, that idea in polynomial? Let's define the degree of a polynomial. The degree of a polynomial is the highest of the degrees of the terms. How do we find the degree of a term? The degree of a term is just the sum of the exponents of the term's variables. For example, if we want to find the degree of 8x cubed plus 4x squared y squared, we have to identify first the degree of each term. The degree of the term 8x cubed is 3. Since there's only one variable, then the exponent of that variable will serve as the degree of the term. Let's examine the degree of the second term, 4x squared y squared. What are the variables involved in this term? These variables are x and y. What are the exponents in these variables? We have 2 and 2. To get the degree of this term, we have to get the sum of the exponents of x and y. And the sum of 2 and 2 is 4. Therefore, the degree of 4x squared y squared is 4. Now, to get the degree of this polynomial, we have to get the highest degree. And the highest degree is 4. Therefore, the degree of 8x cubed plus 4x squared y squared is 4. It's not 3, it's 4. All right, let's have the second polynomial, x squared over 2 plus 5x minus 7. There are 3 terms in this polynomial, and we are going to find the degree of each term, starting with x squared over 2. There's only one variable, so the degree of x squared over 2 is 2. It's the exponent of x. The degree of the second term, 5x, is 1. It's the exponent of x. And for the last term, negative 7, the degree is 0. The degree of a non-zero constant is 0. So if you are going to find the degree of 1 million, it's going to be 0. If you are going to find the degree of square root of 2, it's still considered as a constant, so the degree is 0. Now let's go back to this polynomial. What do you think is the degree of x squared over 2 plus 5x minus 7? We're just going to get the highest degree, and the highest degree is 2. Therefore, the degree of this polynomial is 2. And for the last polynomial, 3 squared, there's only one term, so the degree of this term is already the degree of this polynomial. Since this is a constant, then the degree is 0. Again, the degree is not 2. Remember, we're just going to consider the exponents in the variables, not exponents in the constants. So 3 squared is the same as 9, and the degree of 9 is 0. Next, let's have adding and subtracting polynomials. We already have discussed on how to simplify algebraic expressions. To simplify algebraic expressions, we are just going to combine similar terms. These are terms with the same literal coefficients. And that rule still applies in adding and subtracting polynomials. So to add or subtract polynomials, we're just going to combine similar terms. For example, number 1, add 4x squared plus 5x plus 1 and 7x squared minus 9x plus 4. In this example, I'm going to present 2 methods, the horizontal addition and the vertical addition. Let's have method number 1. We're just going to simply add the given polynomials. Our next step here is we are going to group similar terms together. So we can group 4x squared and 7x squared together, 5x and negative 9x together, 1 and 4 together. Take note, grade 7, that you can only do this if there's no negative here, or there's no number here, and there's no negative here, and there's no number here. 4x squared plus 7x squared will give you 11x squared. 5x minus 9x will give you negative 4x. 1 plus 4 will give you 5. This is the simplest form. Let's have method 2. In method 2, we're going to add the 2 polynomials vertically. When you write the polynomials vertically, make sure that similar terms are being aligned. Meaning to say, we have here x squared aligned, terms containing x aligned, terms with no variable aligned. And how do we proceed? Just add 4x squared and 7x squared. That will give you 11x squared. You add 5x and negative 9x. It will give you negative 4x. And add 1 and 4. It will give you 5. This is the final answer. Let's have example number 2. And this is going to be our last example in this video. Subtract negative 3y squared plus y minus 2 from 4y squared plus 7. It says here, subtract this one from 4y squared plus 7. It means that we are going to write 4y squared plus 7 first, and then minus negative 3y squared plus y minus 2. Our next goal here is not to group similar terms together. Not yet. Why? Because of the negative sign here. We have to consider the negative sign here first before we proceed to the step grouping similar terms together. So how do we do this? We're just going to get the opposite of each term inside this grouping symbol. So the negative 3y squared becomes positive 3y squared. The positive y becomes negative y, and the negative 2 becomes positive 2. No more grouping symbols. After this step, we can now group similar terms together. So we can group 4y squared and 3y squared together. We can group 7 and 2 together, and we have here negative y. 4y squared plus 3y squared will give you 7y squared. Just bring down negative y. 7 plus 2 is 9. This is our final answer. And for method number 2, we have 4y squared plus 7 minus negative 3y squared plus y minus 2. Again, if we're going to do method number 2, make sure that similar terms are aligned. Before we can combine similar terms, we have to distribute first the negative sign to each of the terms inside the grouping symbol. So this now becomes positive 3y squared negative y plus 2. 4y squared plus 3y squared is 7y squared. Bring down negative y. 7 plus 2 is 9. And this is our final answer. That's it, grade 7. I hope that you learned something from this video. You just learned about the definition of polynomial, the types of polynomials, the monomial, binomial, and trinomial. You also learned about degree of a polynomial, degree of a term, and how to add or subtract polynomials. I'll see you in my next videos or in my Zoom classes.